Hi, we are CaseCargo, and this is our conceptual design review on February 24th, 2025. Our project is a drone delivery system with stakeholders consisting of the case community, the EMAE 260 class, and external suppliers, with a team sponsor from Dr. Suneva Collins. So, in response to a growing demand for last mile delivery systems across the country for commerce, we have been tasked with creating a drone delivery system that can quickly and safely deliver packages across the case community, starting from a centralized location and being able to supply resources and packages to the case community from a certain radius. Consists of a 13-week time span to complete the project that will meet requirements for safety and quality. We would be responsible for sourcing the electrical, mechanical, structural components of the drone, as well as being able to express what the design is through computer-generated models, analysis, and drawings, and completing the drone with some manufacturing and financial evaluations. We will not be responsible for supplying a physical or software prototype whatsoever, as well as any electrical schematics or the complete infrastructure necessary for allowing a drone delivery system like this to operate in the case community. The deliverables for this project will consist of a project plan review, conceptual design review, and detailed design review with deliverables for each one.
Based off requirements set by the customer, we were able to derive standards that we will be able to hold our design to. Some of these include our drone will not be controlled by a person, whether in the drone or via remote control. This drone will also be durable and be able to function in all weather conditions. Along with this, our drone also needs to maintain safe flight patterns. For this, we will make sure that our drone won't interfere with any traffic safety regulations in any state. And along with this, we're also aiming to minimize cost, which we set a target of around below 150K. Along with being durable for weather, we also want the drone to be able to last. And we decided that this drone should have a lifespan of no less than 3 years. And along with that, the drone needs to be able to complete any type of trip where it needs to deliver a package there and back on a single charge. Along with that, when it comes to carrying capacity, we decided that the drone must be able to carry up to a 4-pound package.
So we settled on four potential designs for our initial designs, and these were based on a lot of the research we did on existing technologies, on products that exist as well, and some technical calculations. So this first design here has 4 propellers, and then it has a protective shield on top to protect it against harsh weather conditions like rain or snow. And then you can see the lifting mechanism at the bottom there. It has rubber wheels that clamp down on the package and then can roll out the package when necessary. The second design has 5 propellers for more lift, and then it has a carbon fiber box at the bottom that carries the package with doors that open to release it. And you can also see the vision system on the body there with the camera.
The third design we made is a very standard, excuse me, quadcopter drone. The main innovation here was the legs coming down from each of the propellers to kind of stand on, and then a locker system below that's attached via winches and can be raised and lowered from the drone.
The fourth design is a quadcopter drone. It has a double camera, one at the front and another at the back. The main innovation in this design is it has a double stand carrier, which has a package size adjusting knob, which allows us to carry packages of different sizes.
So to pick the design that we wanted to move forward with, we made a weighted pew chart. And since we didn't have a datum to compare it against, what we did is we just compared it against the criteria. If it met it to a satisfactory or an average standard, then we put a 0. If it excelled, then we put a positive, and if it needed improvement, we put a negative. So you can see here how we weighted each criteria and the outcome for the pew chart. And it carries on over to the second page as well. And then here you can see the summation of the results at the bottom there.
Some technical information. The aircraft needs a thrust of above 75 pounds to remain able to move in a satisfactory manner. Using some basic thrust calculations, we were able to calculate what kind of motors we would need to be able to use, ranging between 800 to 1,200 rotations per minute. Battery efficiency, we require low battery weight range, 500 grams to 1,000 grams, due to the fact that the drone will be carrying large packages, and so we need the rest of the drone to remain as light as possible. The drone needs to be maintained or experience maintenance less than once a month, and it must be weatherproof and suitable for cold and hot weather.
For the economics and manufacturing of our drone, as far as manufacturing goes, we're going to be manufacturing our frame via third party. This is because if you look at the materials we're going to be using for the drone, we're going to be using carbon fiber to make the frame of the drone, and carbon fiber is very hard to work with, and we would need some very large scale industrial machines in order to form a frame out of carbon fiber, which isn't doable for this project. But as far as the landing gear and package carrying components go, those will all be made in-house because wire mesh, rubber, and fastening components are easy to work with. And on top of that, assembly of the frame, once we get it from the third party, along with the components that we make in-house, will be done in-house as well.
Our initial economic evaluation for one drone contains initial cost, operating cost for 3 years as the requirement stated. And so it comes out to be around $5,150 to $7,150. This includes outsourced components, as mentioned earlier, and also purchase components, and the maintenance cost that is going to occur during the 3 years when the drone is in use. And so, as it was mentioned earlier, the frame, the landing gear, and the mounts would be made and designed by us or outsourced, but this is to so we are able to fit it for our needs, and it is also reducing costs as we are not buying an already designed gear. We would, however, buy the motors, propellers, sensors, batteries, and software. Some of these are really hard to make, and also it would not be cost efficient for us to make it. Some of the options that we're looking at right now, I mentioned on the slide, these are cost efficient and also should be small so they would fit in the drone and help stabilize the drone so the drone is not breaking the packages.
Our design concept revolved around a quadcopter drone. It has a dual camera, one at the front and one at the back. It was inspired by the Aris M900 4-axis industrial drone that has been used to carry packages before, and it has a 2-stand package holding system. The battery that it currently has is the 6S 22,000 milliamp semi-solid state LiPo battery. Then for the design concept meeting the requirements, our design that we've decided on is unmanned. It doesn't need a remote control system. It is able to function in harsh weather conditions of Northeast Ohio, including very cold winters. It follows all the air traffic safety protocol. It follows the local regulations and abides with the safety of our state regulations as well. And the costs of this drone are quite lower than the expected costs by our marketing research team, because we almost half the price that we're going to use to make the drone. And the drone is also durable. It's designed so as to ease maintenance. It should be able to work for 3 years with a monthly servicing. And yes, the drone's carrying capacity, this model is able to carry almost 4 pounds, and it can also hold different package sizes.
Here's our updated Gantt chart. We are currently continuing to work through both design and market research, and soon beginning the detailed design phase. Our next due date is the product design specification due March 2nd.
Thank you so much for viewing our presentation. and we are open to any questions and feedback.